Hey there, physicists. Welcome back. We're going to work on some kinetic energy problems. One thing that I forgot to point out in the last video is that I did take a little screenshot of your equation sheet, and it's on the last video and it's on here too with the equations on it so that you know kind of where to look for those when you're using your equation sheet on a quiz or a test. So we're going to do a couple kinetic energy problems. These are both from your textbook, so if you want to go back and refer to them, they are right there as well. Just trying to keep it as simple as I can for you. Okay, so here is sample problem B. It's about Silvana Cruciata, who is a runner from Italy, says that she ran 18.084 kilometers in 1 hour, which was a world record at the time. If Cruciata's kinetic energy was 694 joules, what was her mass? So we're going to approach this problem using the same method that we have all year long. It's the guess method. And I just want to remind you of what that is because we haven't used it formally for a little while, and sometimes it's just nice to remind yourself. Whenever you're dealing with these problems, the easiest way and the most surefire way to get them to work is to use the guess method. So the first thing in the guess method is givens. So we're going to go ahead and start with a list of givens. And making out a givens list is really nice because it just kind of gets everything out there so that you know as much as you do from the problem. So reading through the problem, I'm going to look for some numbers or look for some other details. The first one that I see is this 18.084 kilometers. Now, it doesn't say exactly what that is, but I can use my clue of the units to figure out what kind of a measurement it is. It says kilometers, which I know is a measure of distance. So that tells me that this is kind of like her distance or maybe her displacement. And then the next thing that I see there is the 1 hour. And so that 1 hour is a measure of time. So I've got a distance, I've got a time, and then it also says that she has a kinetic energy. This one's really explicit. It says kinetic energy, so that's E sub k is equal to 694 joules. So those are the three pieces of information that are in the problem. And then the next thing that it asks is the unknown, which is what's her mass. So I'm going to go ahead and write that kind of in that list as well, but that is the second thing in the guess method. That is my unknown. Next thing to do is to write down an equation. So I know that I'm dealing with kinetic energy here. I only have one equation that I know with kinetic energy, and that's the 1/2 mv squared. So I'm going to go ahead and write that down over here. I'm going to say that energy kinetic is equal to 1/2 mv squared. And then we'll just make sure that we're ready to go. So in my givens list, I've got kinetic energy, so that one's good. I know that I'm looking for the mass, so it's good that it's in the equation. But if I look at my givens list, I don't see a list for velocity. So we need to be a little bit creative here. We need to figure out what that velocity is, don't we? Let's take a look. I do know position or displacement and time. And recalling what we did so many months ago, I can recall that the velocity is change in position over time. So we're going to have to do a little bit of calculating. So I know that this is 18.084 kilometers per hour, or in 1 hour. Maybe I'll write it like that. But you might recognize that, those aren't base units. That's not what we usually use in physics. So we'll actually need to do a little conversion. Now, I do want to be clear that on a quiz or a test where we're assessing like standard 5.1, we're not going to ask you to do the conversion, but that's not to say that it's not a good thing to do or thing to practice. So let's go ahead and jump in and do that real quick. So just a friendly reminder that as we're converting from kilometers to meters, we're going to just multiply by a factor of 1. So this is going to be 1 kilometer is equal to 1,000 meters. And if you don't remember those conversion factors, they are on your equation sheet. So definitely take a look there to see if you can find them. Why do we set it up that way? So that we've got kilometers on the top and the kilometers on the bottom. They're going to cancel out. And so we're going to get something in terms of meters. And we also want it in terms of seconds. So I'm going to put 1 hour up here, which is 3,600 seconds. And again, if that's not seeming super memorable to you, you can also recall that 1 hour is 60 minutes and 1 minute is 60 seconds. So you can convert in kind of that two-step conversion as well. So those hours are going to cancel out. And then we will just do some multiplication and division to find out that the velocity that she's moving in meters per second is 5.02. That's what I calculated when I did it. Hope I did it right. All right, so now we've got our energy, we're looking for mass, we've got our velocity, so now we can really jump in and use our equation. But our equation isn't solved for mass, so we need to do a little algebra, right? So we need to figure out how to get mass all by itself. So let's just take a look. We're basically just going to peel back the layers until we get mass all by itself on one side. I'm going to multiply by 2 on both sides. I'm multiplying by 2 to get rid of by 1/2. Okay, and then the next step that I'm going to do is to divide by v squared. And the reason I'm dividing by v squared is to get rid of the v squared. And now the only thing I have, if you can see it on the right-hand side of that formula, is the m. So I'm just going to rewrite this in a nice, easier to read way. And now I've got mass is equal to 2 times the kinetic energy divided by v squared. And now I'm ready to do my substitution. Let's do that. So I've got 2 times 694 joules of kinetic energy divided by 5.02 meters per second. Don't forget to square that 5.02. If you do, it's not going to work out. So make sure that you do that. And then plugging that in, we should be able to find that the mass of this runner was 55.1 kilograms. There you go. All right, I do have one other kinetic energy problem for us to look at, solving it for a different thing. So let's go ahead and take a look at this one as well. So we're going to use the guess method as well. So we're going to start with our givens. The question says, calculate the speed of an 8 times 10 to the 4th kilogram airliner with a kinetic energy of 1.1 times 10 to the 9th joules. Now this one has a little bit of a wrench thrown in it too, because it has everything written in scientific notation. But we worked with scientific notation. You've been doing it for a while. Don't be afraid of it. You absolutely can handle it. I'm just going to write it out. So givens, I almost wrote guess there. What do we know? We know that this thing is 8.0 times 10 to the 4th kilograms. That kilograms is going to jog my memory and say, oh yeah, kilograms is a measure of mass. And then this one says that it has a kinetic energy, so that's E sub k of 1.1 times 10 to the 9th joules. Those are the two things I know, and our unknown in this one kind of hit at the beginning of the problem. It says calculate the speed. I'm going to interpret that as a velocity. Remember, speed is just velocity without a direction. So we're going to go ahead and write that as velocity. So those are the things that we know. We can go back and look at our equation. It's 1/2 mv squared is equal to the kinetic energy. So let me go ahead and write that down. So E sub k is 1/2 mv squared. I chose this problem in particular to make sure that we knew how to solve for v. So let's go ahead and do that. Just like we did in the last problem, when we're trying to, before we do our substitution, we need to get our equation so that it's set up to be able to be solved. So we need to get v all by itself. So just like in the last, we're going to start by multiplying by 2 to get rid of our 1/2. Okay. Now, this time we're going to divide by m to get rid of the m. So now we've got an expression of 2ek divided by m is equal to v squared. Don't forget that that squared's there. We need to get rid of it. How to undo a squared? Well, we're going to take the square root. Kind of messy and ugly here, and I'll rewrite it in just a moment so that you can see what it looks like. So the velocity for our airliner is going to be equal to the square root of 2 e sub k divided by m. All right, so now we can do our substitution. Go ahead and write that out. So that's going to be the square root of 2 times, now these numbers look big, they are big, but we don't need to be scared of them, okay? So it's 1.1 times 10 to the 9th joules divided by 8 times 10 to the 4th joules. And you should be able to just plug those right into your calculator using the little E button. If you're not sure how to do that, please reach out to your teacher and ask. Or I know that there are videos that we had from before that that have that as well. So if you need help, please advocate for yourself so that you can know and not be scared of it. All right, so when we plug those values into our calculator, I got a velocity of 165.8 meters per second. Hopefully this is helpful. Have a great time doing calculations with kinetic energy.